vectors. So a vector is something that has both magnitude, which is size, and also direction. And the way we show that is, if I was to draw one, it would look maybe like this. Call that vector A. And the length of it, that shows the size, and then the direction is shown by this arrow. So that's what a vector looks like, and there are different ways we can write them. One being, so in your exam papers there'll be bold letters, maybe something like that. But that's just stuff I have to write, so that's not what we do. I personally write them like this, with a little arrow on top. Another way you can write them is A, B. So for example, if I do A here and B up here, and we're going that way, that's the vector A to B. And we can also write them as column vectors, which look like this. This is actually my favourite, it just makes a lot more sense to me. And what this actually means is 1 unit right and 2 units up, so it's just kind of like a coordinate but in a column. So if I started here, so let's say I'm at a point here, P, I'm looking at this column vector, I'd go 1 unit to the left and 2 up. That would be 1, 2. So what happens if we take a vector and we multiply it by a scalar? Now a scalar, this might be a new word, this is just, call it a normal number, although who knows what normal is. So a vector has magnitude, size and direction, and a scalar just has magnitude, size with no direction. So a scalar could be 3, it could be a half, it could be -2. So what happens if we just take our normal numbers and we multiply it by a vector? A, and A looks like this. And over here I'm going to do 2A, and that is just 2 times the length of A. So we're multiplying it by the scalar, which is the size, so we're just increasing the size by 2. So I have to keep the same direction, so exactly like that, but this, not completely to scale, there would be 2A. So I've just multiplied the length by 2. Important thing to note about this is that these 2 lines here have the same direction, so are parallel. Okay, so they have exactly the same direction, I've just changed their length. What if we look at doing this with column vectors? So I have, if I want to do 4 times the column vector 1, 2, any column vector, you just multiply each part of the column vector, so that would become 4, 4 times 1, and 4 times 2, 8. I could do it with a fraction, so if I have a half, and then I'm going to do multiplied by that vector. So here is your scalar, and here is your vector. So I'm just halving the length of that vector, but the direction will stay the same. So that would be a half times 2, which is 1, and 4 times a half, which is 2. So let's look at adding and subtracting 2 vectors. And this is actually not too bad, but it's made much easier with a picture. So if I have a vector A, and I want to add vector B, that means I go along A and then I go along B, and direction is so important, otherwise they wouldn't be vectors, so always think of direction. So I'm going to call this is A, and this is B. So A plus B, I start here, and I go along A this way, because this is the way the arrow is telling me to go, direction is very important. And then, I don't stop there, I also go along B, and then go this way, because that's the way my arrow is telling me, and I end up here. So I've gone from here, A plus B, and I've ended up here, and therefore this line here, that vector there, from there to there, is A plus B. Let's have a look at subtracting. So let's say I have C minus H, you can call them anything, and then I start here, I'm going to go say this is C, this is H. So C minus H, I'm starting here and I go along C and I go this way because it's positive C, the arrow is telling me to go this way, so I'm here. Now I need to subtract H, and that just means go the opposite way. So if we were adding H, we would go, we would have to follow the arrow this way, but if we're subtracting H, we go the other way round, so we can kind of backwards down the line. So we'd go the way the arrow is not facing, which is this way, and we end up here. So all in all, we've gone from here, C, minus H, the other way along H, and then this here, gone from there, and we've ended up there. So this is now C minus H. If we did that with column vectors, this is why I love column vectors, it's so lovely. So then we take A, just copy them in, here's A, there's A, plus B, vector B, 5, 6, and in total that means we just add them through. So 1 plus 5 is 6, and 2 plus 6 is 8. So in total, A plus B would be that column vector. If we did A minus B, that would be A minus instead B. And again, do the exact same thing, just follow it through. So 1 minus 5 is minus 4, and 2 minus 6 is minus 4. With this, you can always pull out, so I can pull out the negatives. This is the same as minus 1 times 4, 4. Because as we just did, if you multiply that through, you'd get minus 4, minus 4. But we've also got 4's common, so we can take minus 4 out, and then that would be 1, 1. And let's just check that's the same thing. So you can leave it like that, and this is the same thing. Because if we did our scalar multiplication with our vector, we would have minus 4 times 1, which is minus 4, and minus 4 times 1, minus 4. So it is in fact, this is the same as this. And the other way you can write this is just minus 4, forget this multiplication there, 1, 1. So you can pull out a factor basically. Same with if we look here, we can simplify that down, just like doing a fraction ratio. So pull out a scalar, a number common to both. So 2 goes into both, so I can take 2 out. And then here I would have 3, and here I would have 4. Because 2 times 2 is 6, and 2 times 4 is 8. If I have this line here, and I want to show that C is on the same line as AB, that it lies on the line. So basically what I have to show is that it is going in the same direction. So I know it's a point on the line, but I need to show that if I move from C to B, this bit here, we're going in the same direction as if we go here. So this is all the same direction, we're just maybe going a shorter distance, so we're scaling multiple of it. So we're scaling that down, but it's in the same direction. So to show same direction, so that they lie on the same line if it's a point on the line, because also if it's not a point on the line, this would still be the same direction, but it's not on the same line because it didn't start on the line. And it might say that AB to BC, so AB to BC is in the ratio 3, 4, 5, we might say 2 to 3. Okay, so that's telling us AB to BC in the ratio 2 to 3. So the way I look at that in total, if I add 2 and 3, I get 5. So I'm going to break that into 5 parts. 1, 2, 1, 2, 3, 4, 5, and then 2 of those parts are in AB, 2 of those parts are in AB, So here, so 2 of the 5 parts are in AB, and then 3 of the 5 parts, 1, 2, 3, are in BC. So if I was to say this whole vector here was 5A, so that's the vector from A to C, here, A to C, I would know that this, the 2/5, so that would be 2 parts of my 5, so that would be 2A, so this bit here would be 2A, and then this bit here would be 3A, and that's if that was 5A, for example. Again, we'll have a look at this in practice now. We'll start with some easier questions and then build up to some harder ones. Right, so this is question 1, and this is just sort of doing your adding and subtracting in your scalar multiplications. We've been given 2 column vectors, A, 4, 1, and B, 3, 2. We don't actually even need to understand what's going on at the moment. It's just saying A plus B, and this is, if we substitute in A, 4, 1, plus B, plus, this is vector B, and we just know it's exactly the same as normal adding. 4 plus 3, add these two, is 7, and 1 plus 2 is 3. So that's that bit done, nice and easy. What about this 2A minus B? So we've got 2 times A, so let's work out 2A over here, which is 2 times A, which is 2 times 4 is 8, and don't forget also do this one, 2 times 1 is 2. What about minus B? Wait, we'll just leave that there. So 2A here is 8, 2, and then we're going to subtract minus, and then B, 3, 2. So let's do that, just like adding but subtracting. 8 minus 3 is 5, and 2 minus 2 is 0. Okay, so that's those two. Then part 3 is a bit different. So we've got given a vector C, and in a column vector form, 5 minus 4, and it says draw C on the grid from point P. So this from point P is quite essential, and it's given us a point here, so you have to start here. So let's have a look at C. What is this telling us? This is telling us we want to go 5 right, this bit here, this is the along, kind of like the X, if you're doing an XY axis, and then this is telling us to go 4, and then because it's negative, down. So 5 across, 1, 2, 3, 4, 5, and then minus 4, so 1, 2, 3, 4, oh, thank goodness I did enough. Okay, so we started from point P and we've ended up here, so don't forget that means we have to draw this line there, and also you must remember direction, so then draw on this arrow here. We've gone from this way, there to there, this way, and then I would label that C. Okay, so this is the first part of this question. A is 0.5 minus 1, and B is 4 minus 3 as a point. Write AB, the vector AB. So whenever we have AB as a vector, this means that you do B minus A. So if we put that in our column vector, so we've got 4 minus 3 minus 5 minus 1, so that's B minus A. And then if we do that, we've got 4 minus 5 is minus 1, and minus 3 minus 1 is minus 3 plus 1, so that's minus 2. So we can always take minus outside and do that if you want to. Second part of the question. Okay, so C is a point 1, 6 and D is a point minus 3. That is a 9. write down CD. So CD, we don't really use CDs anymore, but there we go, is D minus C. So the vector D is minus 3, 8. Vector C is minus 1, 6. Oh, that's not an 8. That's a 9. I've just drawn it badly. 9, 9. So what we get here, we just subtract minus 3, minus 1 is minus 4, and 9 minus 6, 6, 7, 8, 9 is 3. So that is C to D. If we were going to try and draw why this happens, if I draw this might help. So point A is 5 minus 1, so I'm going to call vector A 1, 2, 3, 4, 5 minus 1, A. B, 4 minus 3, so I'm going to go 1, 2, 3, 4, 1, 2, 3, and call that B. So this is A, and this is B. I am looking for A to B. That is A to B, starting at A to B. So how would I actually do that visually? I've started at A, but I don't know this is what I'm looking for. I've only got these pieces of information, so I need to go backwards along A, because the arrow's going this way, but I want to go this way. So I need to go negative A, and then I need to get to B, so I'm going to go this way, along B, the correct way, the arrow's going this way, plus B. So that is why we normally, put the negative after, which is the same as B minus A. So that is why A to B is always B minus A. Okay, so this is what the question gives you. It's given you a picture and it's told you that OA is 5A, OB is 3B, and M is the midpoint of A. So this information here, good to read it, but it usually puts it on the diagram for you. And the first question, find AB. So we know A to B, we want to go from here, A to B. But all we know is that M is the midpoint, we don't actually know what this is. So we've got to use the parts that we do know and try and maze our way there. So I know, so A to B, I'm going to go from A, can't go this way, so I'm going to go this way, but because I'm going this way, that's the opposite way to the way this arrow is going, so I have to go put a negative, switch the way, minus 5A, and I'm here. And then to get to B, I just need to go along here, so I'm going to do plus 3B. Going this way, same way as the arrow, so all good. And I've gone from A, minus 5A to B plus 3B. Okay, so we found AB. What about finding AM? So let's see AM. Now we want to shuffle our way to AM. So we know that AM, this is the midpoint. Midpoint means it's halfway between here and what's here. Here is A to B. So this here is half of the A to B vector. Okay, half A to B. Do we know what A to B is? Yes, we just worked out. That's helpful of our question. So we just, AB, there it is, put it in there. Half it, so we've got minus 5 over 2, A, expand the bracket, and plus 3 over 2, B. So times there, multiply there. Okay, so there we go. This question is kind of helpful because it's giving us that part A was useful for part B. Now let's do part C, so O to M. What do we need from O to M? So let's say we go there to there, that would be O, starting at O to M. Where have we gone? We've gone from O to A first, and then we've gone from A to M. Add a Y, that's my name. Okay, O to A, what's O to A? It's given us in the question, this is the 5A, we can see from the picture. And then plus, what's A to M? We just worked it out. Okay, get rid of my plus, it's minus. So A to M, this bit, minus 5 over 2, A plus 3 over 2, B. Just like simplifying in algebra, collect your like terms. 5 over 2, A plus 3 over 2, B. So now we're moving on to our exam questions that are a bit harder on vectors. And this is what we've been given. So we've got this drawing and then this information was already on there. OA is 2A and OB is 3B. We've also got given that point P is a point on AB such that AP is in the ratio and then PB 3:2. So if I look at that, is point P is on AB, so this is AB, in the ratio AP, PB 3:2. So I'm going to put it about here. And if I add 3 and 2, that's 5. So I've got 5 parts, 3 of which are from A to P, 3/5, and 2 of which are from the P to the B, personal best. So 2 of the 5 parts are here. Okay, it's telling me now that OP, O to P, is this, K brackets 4A plus 9B, and it wants me to find K. Okay, so first of all, I need to find OP. So, let's find OP. Let's do the jigsaw mapping in our diagram. So what is O to P? How can I get there? I don't know it all yet, so I'm going to go from O, I'm going to go O to A first, there to there, and then I'm going to add A to P. Okay, I already know O to A, so let's put the information in. O to A is 2A, and then I need to add A to P. But A to P we don't know yet. Okay, so now we need to find this part here. So, what is A to P? So A to P is 3/5 of A to B. So it's 3/5 of this line. Okay, what's A to B? So now let's go A to B. A to B. So we can go, we know this, we can go this way along that line, so A to O, and then A to O, O to B. We know both of those things, so for you we're getting somewhere. So we've gone this way, that's the other way of the arrow, so minus 2A, and then plus 3B. Direction is so important, remember. Okay, so we've got A to B. Let's substitute this back in here. So if we do this, 3/5, so A to B is 3/5 of this, minus 2A plus 3B. So that if we multiply out, it's going to be minus 6/5A plus 2, and this one, 9/5B. Okay, so that's A to P, right back here. And why were we finding this again? We've gone really deep now because of, we need to put it in there, so let's substitute that in. So I'm going to write out O to P, the bit we're looking for is 2A plus A to P minus 5/6A, 6/5A plus 5B. Okay. And that, if we do the calculation, so collect your like terms, you've got an A here and a negative 6/5A here. And if you do that, you end up with 4/5 A plus 9/5 B. And let's just remember why we're doing this again. It's told us O to P is this in the question. And we found O to P here. So let's pull out the factor of a fifth here. And they look very similar, except this time, instead of a K outside, this bit is the same. You've got a fifth, so therefore we know that K is a fifth. Okay, so this is our final question, the other thing they tend to do for the hard vectors questions. And this is our drawing, and then again, labelled the information here. OA is 5A, OB is 3B, M is the midpoint of AB. It's also told us that D is a point such that OB, here's D, OB in OD is 3 to 4. So OB, OD. We're already given OB, which is 3, and that's already 3, so it's the exact same number there. So we know that OB is 3, there, OD is then going to be 4. So I'm just going to label, instead of saying that that is 4, I'm going to call this bit here 1, so 1 little b. Because if I added the 3b and the b, I'd have 4b, so O to D would be 4b, which we wanted because this was 3b. The ratios can be a bit tricky. And then we've got C as a point such that another ratio, OC, CA is 4 to 1. So O to C, O to C somewhere, and then C to A is 4 to 1. If we add 4 and 1, we get 5. Okay, so O to C, let's say C is about here, 4 to 1. We know this length is 5A, so that's already divisible by 5, so we can say that this bit here is 4A, and then this bit here would just be A. Because if you add 4A and A up, you get the 5A, and that would be the whole way. Okay, so I think we have labelled everything that we need to, and now let's look at the question. Show that C and D are on a straight line. Okay, so you've seen this straight line. What did we know from the theory? That means scalar multiples, to show they're in the same direction. So what I'm going to do, they don't actually look very much on a straight line, so show that this is a straight line. So what I'm going to do is I'm going to show that I'm going to start at C, start at point C, and I'm going to show that C to M, you want to show that C to M here and C to D are scalar multiples. Because if I show that, I've shown that they're going in the same direction from C, which means they will be on a straight line, and because I've started at this point, they're on the same point and going in the same direction means they're going to be on the same line, if that makes sense. So if I'm starting at C and I show that CM is a multiple of CD, so they're going in the same direction and they're starting from the same point, then they must be on a straight line. Okay, so I'm looking for CM and CD. I'm just going to work with them and then hopefully they're going to be scalar multiples at the end. So C to M. Can I get C to M? So C to M is going to be C to A here and then A to M. Okay, do I know those bits of information? C to A, I do, I know it's A from the ratio, and A to M, I know that is, M is the midpoint of AB, so I know it's half of the A to B vector. Okay, I need this AB vector, I'm going to have to keep going deeper, so A, B vector. So A to B, so we can go, we know this, so negative 5A, because I'm going the other way from the arrow, plus 3B. And that gets me from A to B. Okay, so let's substitute the AB back in here. So I've got A plus a half, AB minus 5A plus 3B. Let's just do some maths. Minus 5 over 2A, so I'm multiplying this out, plus 3 over 2B. I have like terms here and here, so 1 minus 5 over 2 is minus 3 over 2. And I can pull out the factor of 3 over 2 to give me minus A there and B there. Okay, so that is CM. Don't forget this, CM. We also need to look for CD. CD. So where's C and where's D? C, D here. So I'm thinking I'm going to go like that, I think. I think that's easier than doing that. So C to D is C to O. O to D. Right, let's see what we know. C to O is 4A, but the wrong way, so minus 4a. And then O to D, we know, is 3b plus b, 4b. Okay, pull out a factor of 4, because 4 is in both, and we're going to have negative a here, plus b here. Because if you multiplied that out, you would get back to there. Okay, so now let's just compare them both. We've got this, and we've got this. And as you can see, this vector bit here, minus a plus b, is the same as this vector bit here, minus a plus b. So they're going in the same direction. And the other point, both go through point C, therefore straight line. That's what we need to do. You need to show that from one point they're going in the same direction, they're scalar multiples of each other. You are done.